Let's look at a question that kind of encompasses all three things that we were interested in the last video. So wheel and axle, blah 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 blah. Okay, what are we interested in? So we got numbers, 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 and numbers. Okay, so wheel diameter of 250 meters. So big wheel, axle. So this we'll call uh, wheel diameter of wheel is 250 millimeters. And, axle diameter is 50. And the axle 50 millimeters. So we want the velocity ratio, mechanical advantage, and the effort. So we're given these two. We're told that there's a load of 500 newtons, and we're told that efficiency equals 90%. Okay. So straight off the bat, you can see that if you watch the last video, you can see that whenever you're dealing with distances, velocity ratio, whenever you're dealing with loads and effort, dealing with mechanical advantage. So we're giving two right off the bat. And we know that the velocity ratio is diameter or distance of the effort, load, and we know that distance of the effort, you're going to be pulling the big wheel, so diameter of the wheel, or radius of the wheel, whichever one you want to do, over the diameter of the axle. So 250 millimeters. So in this case, there's really, you want them to have the same units. Um, so you you can convert both to SI meters, but since they're in the same units, you might as well just leave them millimeters. So 250 over 50, that's just going to be 5. So velocity ratio will be 5. We're done with that. So next, what can we do? So we know our load. Can we get our effort? Probably not. We don't have that information. But we do know that percent efficiency is equal to your mechanical advantage over velocity ratio times 100%. We know this. We know this. So we can get mechanical advantage. So mechanical advantage is just velocity ratio times percent efficiency over 100%. And you just do that by first dividing both sides by 100, so it cancels this, and then multiplying both sides by VR, which cancels them. So velocity ratio is 5 times percent efficiency 90% over 100%. So it's 5 times 9 over 10, which is mechanical advantage 4.5. Boom, done that. Now we just have one more thing to figure out our effort. So we know from the definition of mechanical advantage, we know that that's equal to the load over the effort. And this is what we're trying to find. So you isolating for effort. If you don't already know the steps, you just multiply both sides by the effort, cancels this, puts effort here, and then divide both sides by mechanical advantage, so cancels this, leaves effort by itself. Or if you have your own way of doing it, like cross multiplying, you can just remember like that, or do it like that. Load over mechanical advantage. We know that the load is 500 newtons. Mechanical advantage is 4.5. So our effort is 111 newtons. And we have everything we need. So we got velocity ratio, mechanical advantage, percent, and effort. So if this question, another key thing, so no, if this question, so if it asks you to find the ideal mechanical advantage. So I didn't talk about this last video, but ideal mechanical advantage assumes, an idealistic situation. So the most idealistic situation would be 100% efficiency, which we know that's not the case. That's why we only work with mechanical advantage. So if we did have 100% efficiency, we know from this formula, we know that, this would be 100, that would be 100. Divide both sides by 100, you get 1 is equal to ma over vr. So essentially, mechanical advantage is equal to the velocity ratio. So it saves you kind of like this step over here. So sorry, this is ideal mechanical advantage. So ideal mechanical advantage. And if the question doesn't really tell you anything about efficiency, you just assume that it's 100% efficiency, or that it's ideal mechanical advantage. So that could be one of the multiple choice questions. So what is ideal mechanical advantage? Ideal mechanical advantage is equal to the velocity ratio, or another way of thinking about it, um, uh, or it can be situation with the mechanical situation with 100% efficiency. These are essentially the same thing.